Hello mathematicians, and welcome to the Chapter 7 review video. Hopefully this helps you get prepared for the test tomorrow. So the first couple questions just ask, is it a proportional relationship? And the way we figure that out is if we make fractions out of each of these, are they all equal? Because to be proportional, the proportion of this to this has to be the same for all of them. So is 1/2 equal to 3/4 equal to 5/6? No, this is not true. So this is not a proportional relationship. Next, we look at this. Is this a proportional relationship? Well, when you look at a graph, is it a straight line? Yes, it is. Does it go through the origin? Yes, it does. So yes, this is a proportional relationship. Is this a proportional relationship? Once again, let's make them into fractions and see. Is 3/6 equal to 1/2 equal to -1 over -2? Well, the negatives cancel each other out when you have a negative divided by a negative. So yes, these are all equal. 3/6 is the same as 1/2. So this is a proportional relationship. Once again, we're looking at a graph, and we want to know, is this a proportional relationship? Well, is it a straight line? Yes, it is. Does it go through the origin? No, it does not. So this is not a proportional relationship. Next, we have to look at some equations and see if they're proportional. The first step is always to say, if I plug in 0 for x, do I get 0 for y? Let's try it. If I put in 0, I get y equals 2. So this is not a proportional relationship. What about this one? If I put in 0 for x, I do get 0 for y. If I plug in 1 for x, I get 6 for y. If I plug in 2 for x, 2 times 6 is 12, and so on and so on. So 1/6 equals 2/12. Yeah, anytime you're just multiplying x by one number, that is going to be a proportional relationship. If you think about the shopping example, if one bag of candy costs $6, then 2 costs 12. 3 is going to cost 18. 4 is going to cost 24, and so on and so on. This is a proportional relationship. And you're going to find the same with this one. If we plug in 0 for x, we get 0 for y. 14 times 0 is 0. And then once again, if I'm just multiplying x by one number, I'm going to get 1/14, 2/-28, and so on and so on. It is going to be proportional. Let's try this one. If I plug in 0 for x, then -15 times 0 is just 0. So this is going to go away, and I'm just left with y equals 15. Does this go through the origin? It does not. It doesn't go through 0, 0, so this is not proportional. What about this one? If I plug in 0 for x, 1/2 times 0 is 0, so that's good. And then am I multiplying it by just one number over and over? I am. If I plug in 2, I get 1/2 times 2 is 1. If I plug in 4, 1/2 times 4 is 2. So if I start making fractions, 2/1, 4/2, if I did it again, I'd get 8/4. Are all these the same? They are. These all are equal. So this is a proportional relationship. All right, so now we have a word problem, which is a little bit trickier. Jordan earns $10 an hour lifeguarding. She worked on Saturday for 6 hours and earned $60. Is this proportional or non-proportional? Well, time and money. If she works 0 hours, she would earn $0. So that's a good sign. If she worked 1 hour, she'd get 10, 2, 20, 3, 30, 4, 40, 5, 50, and 6, 60. So is this proportional? Let's make our fractions. Is 1 over 10 the same as 2 over 20, and 3 over 30, and so on until we get 6 over 60? Yes, those are all the same. So this is proportional. The other word problem says, Bob is saving money to buy a car. He won $50 in the lottery and earns $200 a week at his job. Is the relationship between time and money proportional or non-proportional? Well, let's do time and money. At time 0, he already has $50. So even though every week after that, it goes up a consistent amount, goes up 200, it doesn't go through the origin. At time 0, he started with $50. So he didn't start at 0, 0, so this is not proportional. The next few questions ask us to graph by plotting the ordered pairs. So the first equation we have here is y equals 2x minus 3. And we even get a couple suggested x values to try. So if we plug in these values into x, we get 2 times negative 2 minus 3. 2 times negative 2 is negative 4, minus 3 is negative 7. So xy is going to be negative 2, negative 7. I count backwards 2 and down 7, and I'll get a point there. Next we have our good old friend 0. If I plug in 0 for x, that 2 times 0 is 0, so I get minus 3. And my point is just 0, negative 3. I start at 0, and I go down 3. I'm going to end up right there. If I plug in 4 for x, I get 2 times 4 is 8, minus 3 is 5. So my point is 4, 5. So I go over 1, 2, 3, 4, and I go up 5, 1, 2, 3, 4, 5, and I end up right there. And I take my ruler and I connect the dots. This next one asks us to do 3 over 2x. I'm going to plug in 0 first because I really like plugging in 0 first. And also because anything times 0 is 0. So I know that my point at the origin is one of the points on this line. If I try negative 2, I get 3 over 2 times negative 2. That's going to be 2 times 3 is 6. Divided by 2 is 3, so I just have negative 3. And so x, the thing we plugged in was negative 2, right here. And y is negative 3. So let's find that. We go backwards 2, Then we go down 3, and there's my other point. If I plug in -1, well, anything times 1 is just itself, and then there's a negative sign there, so -1 times 3/2 is just -3/2. So my point is -1, -3/2. That's going to be right in there. And if I take my ruler, it's going to look like that. Finally, x squared minus 1. All right, so -2 times -2 is 4, minus 1 is 3. So my point is -2, 3. If I plug in 0, I get 0 squared, which is 0 times 0, minus 1, -1. So 0, -1. And if I plug in 2, 2 times 2 is 4, minus 1 is just 3. So I get 2, 3. Let's plug these points in. -2 is backwards 2, up 3. 0, I got -1. And at 2, 1, 2, I go up 3, 1, 2, 3. So this is going to look something like that. So that's not a straight line. So let's look at these questions at the bottom. Is this linear or non-linear? Well, this one is definitely linear. It's a straight line, so that's linear. What about this one? Also a straight line, so that's linear. This one, not a straight line. It's non-linear. So this one is just asking us to find the slope. And how do we find the slope? If you look in your notes, you'll see we got to find 2 points. And then we find how much you go up between those 2 points, and you divide it by how long it takes, or how far you have to go over. You have to do rise over run. So let's pick 2 points on this first graph and figure out the slope. I'm going to pick this one right here because it's at the corners of these lines. And I'm going to pick the origin because it's zeros and I like zeros. So we got to figure out the rise over the run. How much do we go up from this point to this point? We're actually going down 3 steps because this line is going downhill. So we're going down 3. And how long does it take us? We have to go over 3 steps to get there. So -3 divided by 3 is just -1. And that is our slope. So what about this second one? Again, we want to pick 2 points. So I'm going to pick ones that are right on the axes here because that makes my life easiest. And again, I got to figure out how much do I go up or down divided by how far I have to go to get there. Well, let's count. 1, 2, 3, 4. So I go up 4, and I go over 2. And I'm still going uphill, so I know it's positive. 4 divided by 2 is 2. And that is my slope. Now for the third one, I again have to pick 2 points. But this time, I'm not picking them on a graph, I'm just picking them out of a table. The y value tells us how far up and down things go, and the x value tells us how long it takes to get there. So how much up or down am I going? From 0 to -3, I actually have to go down 3, so that's -3. How long does it take me to get there? 2 steps. I can't simplify that fraction anymore. That is the slope in this table. This last problem actually has kilometers per hour. So we want to pick 2 points again, and we want to know how many kilometers up are we going and how long in hours does it take us. To get from the first point to the second, we're going up 510 kilometers, and it takes us 5 hours to do it. If I divide 510 by 5, I get 102 as my slope, and the units are kilometers per hour. These questions are exactly the same, except you only have 2 points to choose from. If you want to think about it in the way you've seen it in the tables, 1, 3, and 15, 2. So you just need to figure out how far up you're going from 3 to 2, or down, and how far over you're going from 1 to 15. So to get from 3 to 2, I'm going down 1, and to get from 1 to 15, I'm going over 14. So that is my slope right there. For the middle one, I'm going from negative 116 to negative 50. And it doesn't matter which one I put first. If you look at this equation right here, it suggests using the second y minus the first y, and the second x minus the first x. You can do that if you want. It doesn't matter which one you do first. You will get the same answer. I think it's a little more straightforward to figure out I'm going from 16 down to 0. So I am subtracting 16, and I'm going from negative 1 down to negative 5, so I'm losing 4. The negative signs will cancel each other out, and 16 divided by 4 equals 4. That is my slope. This last one, I'm going to do exactly the same way. My first point here, negative 1, 4. My second point is 7, 4. How far do I go from 4 to 4? Well, that's no change at all. That's 0. I don't go up or down at all. What about from negative 1 to 7? I'm going up 8. And 0 divided by 8 is just 0. So that is my slope for question number 8. All right, so this time I've got to put all of my pieces together. I'm going to have to write an equation, which means that I got to find the slope, rise over run, and I got to find the y-intercept, which means where does x equal 0? Well, let's pick 2 points. How much do I go up from 3 to 4? That's just going up 1. How much do I go over from 0 to 1? That's also 1. So my slope is 1. I look at my table to see if I can figure out where x equals 0. Right here. Where x equals 0, y equals 3. So my y-intercept is 3. The equation I'm trying to write, y equals mx plus b. So I put my slope in for m, and I put my y-intercept in for b. So in this first question, my slope was 1, and I figured out that my y-intercept is 3. So y equals 1x plus 3. In the second question, I will pick these 2 points. How much does the y go up? It goes up 4. How much does the x go over? It goes over 2. So my slope is going to equal 2. Where do I find x equals 0? Right here. X equals 0 and b equals 8. So I just plug my slope in for m and my y-intercept for b, and I get y equals 2x plus 8. On this last one, they're trying to trick us again because they don't have an x equals 0. We're going to have to make it ourselves. It's not enough that we have a y equals 0. We need to have an x equals 0 in order to find our y-intercept. Luckily, it's a pretty easy pattern. 5, 4, 3, 2, 1, 0 matches with 2, 4, 6, 8, 10. So when x is 0, y equals 10. So let's pick 2 points. How about these 2 right here? How much does y go up from 0 to 10? It goes up 10. How much does it go from 5 to 0? It goes down 5. So my slope is 10 divided by negative 5 is negative 2. To write my equation, I just put in the slope, negative 2x, and I put in whatever the y value is when x equals 0, plus 10. And that is the equation for the final question. Once again, it's asking me to write an equation. Luckily, the y-intercept is really easy to find. It's just wherever the line crosses the y-axis. This one crosses at 4, so right away I can write plus 4. I'm halfway done. The one on the right crosses at 2. I can write plus 2. I'm halfway done there. So now all I got to do is figure out the slope. Well, here's 1 point, and here's another point. My first point is at x equals negative 4, y equals 0. My second point is at x equals 0, y equals 4. So I can either use my table to figure out the slope, or I can just count. 1, 2, 3, 4, up. 1, 2, 3, 4, over. So my slope is just 1. Putting it into my equation, y equals 1x plus 4. On this one, I'm going to use the easiest points I can find. This one is right on an axis, and so is this one. So how much do I go up? Well, in this case, I'm going downhill. So I'm going down 2, 1, 2. And how much am I going over? 1, 2, 3, 4, 5, 6. So my slope is negative 1/3. Plugging it back into my equation, I get negative 1/3 x plus 2. Now we get to do my favorite thing. We get to plot graphs from an equation. Right away, I'm going to look at this last number because that tells me where my line crosses the y-axis. Crosses at plus 1, so I'm going to put a point there right away. Now I'm going to plug in a couple values. When x equals 0, I get 1. When x equals 1, 1 plus 1 is 2. When x is 2, 2 plus 1 is 3. So it's just going up along there. And if I grab my ruler, it's going to look just like that. The next one doesn't have any final number. Wonder what that means. Let's plug in 0 for x. And look, I get 0 for y. If there's no number after the x, that means it goes right through the origin. And now that I know that, I can look at the slope, which is up 3 over 2, and just go up 3 over 2, up 3 over 2, up 3 over 2. I don't need to plug any more points in down here. I could. I would still get the same answer. But using the slope is kind of like a good shortcut. All right, this last one, if I look at the number at the end, I know right away that right down at -8 is where it crosses the y-axis. So let's plug in a couple numbers. 0 gives me -8. 2 times 4 is 8, minus 8 is 0. So I can plot it here. Or I can just look at the slope, which I know is 4, and I know I'm going to go up 4 over 1. Starting at my y-intercept, I go up 1, 2, 3, 4 over 1. Up 1, 2, 3, 4 over 1. And I just keep doing that, and I put the dots together, and that is my line. All right, this is the last question. If a bike rental costs $10 for the helmet and $5 per hour, what is the slope of the line? Well, if I think about it, what's going to happen is every hour, my cost goes up $5 every hour. So the $5 per hour is the cost that represents the slope, because when I have the cost going up like this, every hour that I go over, it's going to go up $5. 1 hour over, $5 up. 1 hour over, $5 up. So 5 over 1 is the slope. What is the y-intercept? Well, at time 0, the cost is $10 for the helmet. So right when I walk in the door, I'm going to have to pay $10. So the y-intercept in this situation is the $10 fee that I got to pay for the helmet. So what is a linear equation? A linear equation is y equals mx plus b. My slope, we figured out, was 5, and the y-intercept, we figured out, was 10. So my equation is going to be y equals 5x plus 10. Which makes sense. If I rent it for 0 hours, it costs $10. After 1 hour, it's $5 more. $2, it's going to be 2 times 5. $3, 3 times 5, and so on and so on. So how much would it cost to rent for 3 hours? I just plug in 3, and I get 3 times 5 is 15, plus 10 for the helmet equals $25. And for extra hard question, if I budget $50 for the bike, how long can I ride? That's a hard question. $50 equals 5 times some number of hours plus 10. Subtract 10 from both sides. I get 40 equals 5 times x. Divide both sides by 5. Those cancel out. And I get 8 equals x. That is how many hours I can ride if I have $50 to spend. This last question here, all of these are going to be extra credit questions. So don't worry too much about translating this type of question into the equations. I want to make sure that you know how to do the equations before we get into bigger problems like this one. I hope this helps.